So I'm going to be talking about what is beyond the event horizon. Where are we with containers today? And some of the challenges and opportunities. She's already talked about who I am. I was at Chef, and then I was with these guys, and with these guys. And it turns out I'm recently returning to those guys, going back to Amazon. So my background is in infrastructure and infrastructure at scale, so I really, really enjoy this area. A lot of what I'm going to talk about is going to sound a little bit negative at first. I don't mean it to be. Professional contrarian is actually pretty accurate. But just in case, if you feel like I'm being negative, that's OK. I have a teenage daughter, and I am used to disappointing people. So some of you may know what that's like. So very, very quick recap. I think a lot of you talked about this yesterday. Containers are all about isolation, right? Isolation of processes and C groups, isolation of networking and namespaces behind bridge or virtual switch, and then file system isolation, most of which you can cobble together with services that are given to you by the kernel or the distro today, right? Except that that's a giant hassle. And why are we doing it? It's about repeatability of outcome, it's about the consistency of the thing that you're deploying, and it's about having a finer-grained control over those resources than we've had with any other system before. I am a huge fan. I use containers every day, so I just want to say that now as we start to go downhill, right? For more background, by the way, feel free to use this slide deck as sort of an index of things that are going on out there. Lots and lots of links. This will be provided afterwards, I'm sure. I think this is a great intro presentation, even though it's getting a little long in the tooth, perhaps. So go read more there about sort of the surface area. First point of contention I have, though, is I think there's a false and maybe damaging dichotomy that is building as we talk about containers, and it starts here. The separation of concerns. I get it, and I believe in separation of concerns to an extent, but I think we've spent the last 5+ years trying to bring developers and operations folks closer together. And now we're starting to talk about them again as if they're separate, and it worries me. And it worries me in a way that we talk about how developers are building things, and then again, now we're tossing an opaque unit over the wall, and well, it's real easy for operations because they don't have to do anything because it's a container. In emergent environments, I don't actually think that's true, and it worries me a little bit in the way we talk about it. It's not a big deal, it's something to think about. So what are we currently using them for? Where are we in the life cycle? Hear a lot of talk about microservices. Now, how many of you are developers? So how many of you have been doing service-oriented architecture for years and years and years? OK, that's more than half. The hard part of that, of course, is the functional decomposition of your architecture. There's a lot of feedback in the community now that you should try to run a monolith as long as you can so that you understand the thing you've built, and then you begin to tease it apart. When we start talking about microservices, by the way, I think this is where things end up. It's the right conversation. My concern is that people are trying to divide these things very early in the life cycle. They don't understand the boundaries, and you get lots of things that are decomposed incorrectly, and now they're also harder to connect back together because networking is kind of scary and a sort of a hidden story here at scale. So when we talk about microservices, hugely important, but in some cases I think we put the cart before the horse in the way we talk about it. But of course, it's where we want to get to. We want to get there because of things like this. Continuous delivery. Continuous delivery is important. I really like this. How many of you use Jenkins as well? How many of you use something other than Jenkins but still have CI/CD of some sort? Interesting. Okay. I really love the work that these guys are doing. CloudBees integrating their Jenkins platform with Docker Hub. I really like it because I also spent most of the summer on a contract building that by hand, and it sucked. And I think this is a thing that pretty much everybody ought to have at some level. And the reason we're all doing it is because moving too fast makes you unsafe. And time to market is so important now with web-facing services that anything you can do to make it repeatable in build, repeatable in deployment, is the thing that you eventually end up standing on, right? People are running Docker in production. How many of you were at OSCON? Wow, 1, 2, that's unfortunate. Bridget gave a great talk about what they were doing at Drama Fever. And typically when you talk about folks who are running containers in production, it's forward-thinking, web-facing, smaller startups, as to be expected. And that's something you'll hear me repeat over and over again. Two things I thought were very interesting, though. She says, because all the developers are developing locally using the same containers. So you are getting that consistency, which is huge. But the other dog whistle here at high frequency in the background is production wasn't under config management. So that's a problem. So if one of the things that we're doing with containers is sort of leapfrogging that last generation, maybe that's okay, but the real problem is you weren't doing management properly in the first place. So I think at the end of the day, that is a place that we get to with containers if we do it properly, but we're not there yet. And it takes a village. This is also a slide from Bridget's talk of all the tools that they put together in order to do this. I suspect that this is familiar to lots of people who are using EC2 today or are doing development inside of VMs. How many of you are using tools from HashiCorp, Packer, Vagrant? Yeah. So this is very close to my preferred workflow right now, given the set of tools that we've got. But you notice, building AMIs, using EC2, using Chef to deploy on those instances, and then configuring Docker within them. This is sort of standard at the moment. And then finally, the enterprise. We'll get there eventually. How many of you consider yourselves enterprise people? I was trying to decide. The hands were going up slowly. It's like, do I want to say it out loud? Interesting point here, Tim has, and Tim works with lots of big enterprises, talks to lots of CIOs. Typical enterprise apps are installed once, and they run 24/7, and folks don't like to think about them. What they like to do is they like to nurture the servers those applications run on. Containers are much more about scale up, scale down, that flexibility that you get. And the only way enterprises are going to be able to deal with that is with better automation and orchestration. That's the end goal. I think we spend a bunch of time talking about containers. I think the place we ultimately get to reveal the punchline is Kubernetes, Mesos, something that is a much higher level abstraction to talk about resources, but we're not there yet. This is probably my favorite piece of data in the entire talk. Adrian Cockcroft has been doing talks about this recently. New Relic did some analysis of the lifetime of containers in practice. And a gentleman on the right-hand side there, Randy Bias, was the one who coined the term pets versus cattle. Pets are things that you keep around for a long lifespan, and you nurture them, and you feel sorry when they die. Cattle, you take them out back and you shoot them when they're not useful anymore. Probably eat them, although I don't think we eat our containers. This is really interesting. So you've got the pets, you've got the cattle, but you've got this new thing where workloads only live for a few hours. And you can speculate that some of those are for testing, some of those are for build, so containers that spin up and spin down. But what if there's actually a new class of infrastructure? What if this is purposeful for workloads? And if you can get to full cluster management, it becomes much easier. So I was looking for a biological comparison here and thinking about current infrastructure. Well, what if this is the case? What if containers help you avoid malignant infrastructure? What's a thing that has possibly infinite lifespan, grows without bounds, is complex, and is deadly to the organism? Malignancy. You look at your current infrastructure and things drift over time, you're not sure what your servers look like, maybe this is the road to fixing that. If you actually refresh and rebuild every few hours and you have the management tools to do that, you avoid an entire class of problems. So forget talking about convergence or immutability. In some sense, I think those are distractions. The end goal is this, to avoid drift in your infrastructure. When we talk about classic infrastructure, we talk about this Trinity. I mean, this is the way I grew up defining things. You have a unit of execution, which is usually a server, right? And you put an OS on it, and then you put applications on it. You've got networking to connect them, and you've got some form of storage. My concern, the second point of concern, is that our discussion in the community right now looks a little more like this. We dwell quite a bit on the unit of execution, and honestly, I think it's because as developers, it's the thing we're most familiar with. And networking has actually gotten much more complex as a result. So what we did is we sort of squeezed one side of the balloon and the other side got bigger. We talk an awful lot about units of deployment. And if you look at all of the configuration management systems, infrastructure management systems of the last few years, this is the thing we talk about. Now, when I worked on EC2 and we defined the AMI format, originally we wanted this to be much more like a container image and for people to run them in much the same way you run containers. Opaque, has everything built into it, and you sort of fire and forget. The mechanics of the time didn't allow us to do that. People still really thought of servers. Networks were slow, so you didn't just build these on your laptop and upload them. What you did is you fiddled with them inside of EC2 and resaved them. So we failed to change the paradigm. But it's the track, when you look at this, that everyone wants to be on. But where are we right now? It's not complete because these images are not inherently composable. And I want to talk more about that. I think that's a problem in all of these that's not yet solved. And why is this? Well, we're dwelling on this one piece, but your app includes the infrastructure. All of this is about what happens when your application meets the boundaries at deployment. And right now, I feel like there's a fidelity gap between the thing that you test and the way it's deployed, regardless of whether or not you're using the same container. Because when you drop it onto a machine that has different networking characteristics or whatever it is that changes, you've got a boundary condition that you didn't test for. It's going to react differently. So the container is one interesting part, but you need to consider the whole. Lots of ways around this. It's just a thing that you need to consider. So with all that, is a container a process? Is it multiple processes? Do you treat it like a machine? Depending on who you talk to, yes. Now what do I do, right? Here's the problem. This is one bit of feedback. Adding complexity, because now I'm building up a complex image that now also requires a process manager, as if I were running it like a machine. And admittedly here he says, which is typically a pretty big red flag. Absolutely. So what's the solution to that? External orchestration is the solution, but a lot of folks in practice haven't gotten there yet. They're still trying to reconcile the notion of, I'm running an application inside a constrained boundary that I don't want to fail. And it's inscrutable from the outside, and how do I make sure it doesn't fail? Well, maybe I run a process manager that restarts it. Anybody who's familiar with Erlang probably kind of likes that paradigm too. It's like, oh, things fail, I restart them. That's my background as well. So I went this direction, and I felt dirty doing it. Are containers secure? Now this is I think it's a silly question because it's far too broad. What I'd like people to think about is these 3 points. Is it secure at point of execution? Meaning, do I have access control? Do I have control over who can start the execution, regardless of whether or not it's the command line tools or if I've got it configured in a cluster manager? Is it secure in isolation? Meaning, once it's started, can anything mess with it from the outside? And then finally, do I have integrity in the thing that I'm about to execute? Am I using a trusted registry? Am I using a private registry? How do I ensure that the bits are appropriate? This is where we have the conversation. I think there's great work being done on all fronts, but I think it's silly to ask the question, are containers secure? Why don't we ask about these categories instead? Now, immutable infrastructure, it's so funny when John arrived this morning, he said, I don't think you're gonna like my talk. And I said, I don't think you're gonna like my talk. Truth is, I think we meet in the middle. I like this direction. I like the idea behind it. It's funny, I was having a conversation the other day with Rob Hirschfeld, CEO of a little startup called RackN, and he says, well, of course it's immutable until you do work. And I thought about that, I'm like, wow, that's true, because as a running system starts functioning, you have these emergent conditions. Like, you start an app inside a container. Sometimes that app then pulls in additional configuration from somewhere else. Sometimes it adapts to the network itself and changes in the way it executes. And sometimes after that, you don't have any visibility into how it changed itself. So 500 things that start just alike don't finish the day just alike. And so if you talk about it being immutable, what you really need to talk about, is it changing over time, and can you ask it questions about how it changed, or do you kill it and start a new one if it changes? Because that's becoming easier to do. So I want to just broaden the field a little bit in that discussion. Then we get to this. I believe John mentioned Mark Burgess as well. Super, super smart guy with a mathematical model of convergent infrastructure. We talk about promises. We talk about a point where infrastructure will arrive as you're configuring it. I love the model, and I admit, this is a business I worked in. I believe the model has failed to attract the hearts and minds, because if you've got more than 500 of something, you don't want to sit around wondering if it's going to converge, or if it in fact did converge. In the ideal, it will. In the practical, it doesn't, and that causes fear. Right? So if you at least can start from a clean slate, you want to. And there are lots of folks who are confused about, do I use current tools? Do I use them inside the container? Do I use those tools outside the container? That's a battle that's still to be waged. And then the thing I've mentioned a couple of times, is it visible? Is it observable? Because once you've deployed this thing, whose responsibility is it to actually know if it's executing correctly? We talk so much about how to execute. We don't talk often enough about the correctness of execution. And we think we have that solved in the testing stage or in the build stage. But again, in production, there are emergent conditions. So there's work being done here. But again, this is a part of the conversation. And yeah, every slide on containers has to have at least one picture of containers going wrong. I just love this one. So yeah, the people are doing this. The struggle is real. Here's my favorite part of the struggle. We are not all Kelsey Hightower. And I don't know how many of you saw his demo yesterday, but Kelsey is an expert at this, and he's talking about how easy it is to do all this with Kubernetes. It's easy for Kelsey. It's not easy for me. And I talk to folks out in the world, and that's, we're all on this continuum somewhere, and very few of us are out there. Folks are building up these development environments, starting there, and this bit of feedback it's kind of puzzling. It's like, if the problem is achieving an efficient edit, compile, run cycle, this means your development container is not the same as your production container. I don't know. I mean, the jury's sort of still out to me on the right way to do that. But the coolest piece of advice I've seen is actually from Gilad Bracha, who is a language designer, and he was talking about applications. And he says, debug mode is the only mode. It's like, wow, that's cool. You're right. We should be deploying our applications in the same way that we test them so that you can inspect them and you expect the same outcomes from them when they're in production. So again, we've got this sort of opaque wall, and we like to treat these things as, they're running out there and we don't peer into them. But in fact, there is richness to be had in doing so. And early applications in Smalltalk, in Lisp, to an extent in Erlang, were actually inspectable that way live by attaching to a REPL. I personally think that's super powerful. And we've stopped talking about them in that way. Toolset, I've mentioned this toolset that I've been using lately, a lot of the stuff from HashiCorp. So using Packer to build AMIs, Packer to build images. Interesting bit of rhetoric here, Packer building Docker containers without the use of Docker files. And the contention that this is a simpler mental model because then you can treat them the same way you do configuration management of servers. I like the idea, but I'm afraid it goes in the wrong direction in that these should be inherently different. We shouldn't go back to treating them like servers. Right? This is the whole point of what we're doing, but it makes it really easy. Which brings me to the next point of cognitive load. Joe D'Amato gave a talk that said infrastructure as code might be literally impossible. And my first reaction to that was to pick a fight. And my second reaction was, damn, he's actually right. It was really interesting. This comment here about people changing chef recipes and then breaking the infrastructure, I don't know how many times I saw that happen while I was at Chef talking to customers, while I was outside of Chef as a customer of Chef. It's true. Are we doing the same thing now with the way we build Docker images and the inscrutability of the complexity that we put into our Docker files? Perhaps. So this whole management of workloads is one side of it, but you need to define that workload before it's deployed. And this one, this is at the boundary. This is the boundary issue again. This one, GitHub issue 2267. Go read it. Just makes me cry. And now, like, really, you got internet access. Like, go read it. If we want to talk about immutable infrastructure, at first we have a definition in the Docker file, and then we have a thing that runs. We ought not be tampering with the boundary, except this whole issue is about adding and permuting files in running containers at execution time. So it's a bit like dependency injection, which is great, and I like that as a dynamic pattern, but it breaks the model of immutable infrastructure. So either we're going to be immutable or we're going to fight with dynamic tendencies, one of the two, but we can't ignore it. How do I combine several images? This, I thought, another really, really long GitHub issue, lots of great substance. Great comment here from Solomon. When you rely on Ansible, Chef, or other configuration management to create composable components, you're relying on a leaky abstraction. These components are not, in fact, composable. He's kind of right, and we tried, and we kind of failed to make them composable. That's what we wanted. The problem is we don't have composition now in Docker files either. Right? I love this comment. Yeah, because the apt for containers problem is way harder, and I think that's true. And so this is what we're struggling with. What do I actually put into that file? How many of you are familiar with Greenspun's 10th rule? Nobody? Oh, I love this. This is the notion that any time, for operators, the notion that any time you have a configuration language, it at some point evolves to be Turing complete, and you want to write a whole program in it. You look at some of the issues around Docker files, people want includes in them, now people want loops to do whatever. It's hard. We did the same thing with Chef. Puppet did the same thing. It becomes an entire language on its own. Right? This is where I think we should end up, coordination and orchestration. We want to build cloud-native applications, right? Great comment here. Lacks maturity because the concept has been attacking the problem from the wrong layer in the stack, the infrastructure layer. As an infrastructure guy at this point, after so many years of my career, I agree. Everything is about raising it up to the next level. I think over the last few years, there has been no platform as a service that has been mature enough to do so. Right? Everybody wants to point that direction and say, isn't PaaS going to save us? Well, what's interesting here, this comment. Docker and Kubernetes, platform as a service elements that work because they're separated from the rest of paths. I think that's right. I think these act at the right level because we talk about orchestrating deployment components, the thing I've been railing against, I'm now advocating for, about these deployment components, which inside of them then run the higher level services that you use to compose the platform you want. I think that's right, because typical paths is about being offered a set of services on the outside of your execution. And if you don't like those services, you can't use the platform. This was in some sense true of App Engine, of Heroku, to a lesser extent perhaps of Cloud Foundry. I think they're on the right track. But here, you almost get the luxury of build your own, right? So we end here with Kubernetes and Mesos as I think the eventual outcome along this entire track. You do end up with cluster management where resource scheduling and resource constraints are the thing you actually talk about at the end of the day. And the Weave folks are here somewhere, I think. You should hunt them down, talk to them. I think this is a cool model. The visualization and the ability to build up a fairly complex environment that you can scrutinize as you do it. And their note about non-intrusive, much better fit with modern DevOps approaches. I think that's right in terms of its visibility. And then networking. We talk a lot about SDN. This part scares me. Randy said this, that stuff is just Greek to the average dev. And he was talking about AWS and VPC, but I think the same is true about Docker networking. How many of you look at that diagram and instantly know how to do that by hand? If you have to do it by hand. One guy in the front. Who you work for? I got spots on my team. There we go. The first thing I look at this and I'm like, I hope you're not running spanning tree, because there's a loop here. But anyway, building GRE tunnels between bridges on multiple hosts, you don't want to do this by hand. You have things like Contrail, super cool, also a lot of complexity, full SDN. But we're sort of at this point where this is an exercise still left to the reader, and it's of huge complexity. It's not what developers typically do. There's a cautionary tale here, and this comes from OpenStack. Look at this. OpenStack lost its default networking as development chased SDN. So what I think we need to do in the container community is avoid that exact problem. We need to make this easier. Service discovery becomes an issue because now you place these workloads wherever you do, and now you need to find them and stitch them together. It's related to networking. So after all of that, so where are we going? What are my suggestions? We take these building blocks and we build a complete solution. I told you, I think, I put my thumb on the scale of where that complete solution is. We need to do that to reduce overall system complexity, because failure happens at the boundaries where complexity lies. We need to stop talking about these things and move through them. I think we've passed the era of convergence. We're talking about immutable. I don't think it's quite the right fit. New term perhaps is functional, where we talk about the inputs, the transforms, the outputs. I'm not really sure, but this is an area. And then finally, how do we do this? I think we get to full cluster scheduling. That's sort of the outcome. And like I said, I kind of sound negative. From the words of the bard, I come to bury Caesar, not to praise him, which is actually really not true. But I do think John is the noblest Roman of them all, so thanks, John. And thank you all.